Hi, my name is Amanda Jones, and in this video I'm going to show you some multiplication algorithms. I'm going to show you three. I'll start with our standard algorithm and then show you a lattice algorithm and then connect that lattice algorithm, which I have found that many of my college students use and are familiar with, but I want to connect it to why it works with the partial sums algorithm. So let's get started with our standard. Multiplying 267 times 48. I'm going to set this up like you're used to with the standard. And I think it's good to also mention here with your students that if this was written as 48 times 267, you might want to flip it. Multiplication is commutative, which means that I can 4 times 2 is the same as 2 times 4, so I can flip the numbers, I can commute them around, move them around. And so it's always kind of nice to have the smaller number on the bottom because that's how many lines you're going to have when you add at the end. Okay. Now our algorithm is a slight partial sums. It does the 8 times the 267 and then the 40 times the 267. So it takes not all of the partial sums, and you'll see that when I do all of the partial sums in another algorithm, but it is kind of a variation of a partial product. Okay, I'm saying the wrong word. It's a partial product. All right, so 8 times 7 is 56. So we'll carry that 5 up here and the 6 down with our ones, and that represents that we have the 5 tens and the 6 ones here. 8 times 6 is 48. We do that multiplication and then we add the 5 tens that we had. So we have 480, and then we add, like I said, the 5 tens, which 48 plus 5 is 53. So we'll have a 50 and a 3, same kind of thing, carrying that 5. Then 8 times 2 is 16, plus 5 is 21. Okay, let's switch to a different color to keep this a little bit easier to read. 4 times 7, so now I'm taking the 40 to each value here and kind of dealing with it as we move on and carrying. Okay, not doing all the partial products. I would have 3 partial products with the 8 and 3 with the 4, but we're kind of doing the 8 and then the 40. Okay, but it is a 40, so we are doing a 0 right here, and you'll see that 40 times 7 is 280. So if you kind of think of it, it would be a 2 right here, and then the 80. Okay, 40 times 60, or 4 times 6 is 24. Adding the blue 2, 26. And then 4 times 2 is 8, plus this 2 is 10. And then we do addition, very much like partial sums. We add at the end. We've taken 2 partial products and we add them at the end to group them together. Carrying, as we do with addition, we already learned that. All right, so 12,816 for this. Okay, let me show you a lattice. Like I said, I've seen many students use this. I was not taught the lattice when I was in school, but maybe that shows my age. But not all my students have done it, but I've seen so many of it use it. I think it's worth talking about here. What it does is it sets it up on kind of a grid. So you put the whatever number you want to go on the top. I like choosing the bigger number once again on the top, and then the other number along the side on the right. Okay, and we'll set up this grid. Okay, and it's called lattice because it does take the diagonals just like the lattice addition. And it works so well because it is putting these in the appropriate place value. So this is going to end up being our ones, our tens, our hundreds, our thousands, and our 10,000s, and you'll see that kind of come alive as we move on. And also you'll see those partial products, which hopefully you'll be able to connect now, but I'll also show you the partial products at the end. You can start wherever you want. You're just taking a box and multiplying the number above it times the number beside it. So you could start here if you wanted to, with the 6 times 8 being 48. Okay, 2 times 4 is 8, remembering to put that 0 if it's a 1-digit number, or leaving it blank, just putting it in that lower value, lower corner. Okay, I'll start back over here. 7 times 4 is 28. 6 times 4 is 24. 7 times 8 is 56. And 8 times 2 is 16. So these are partial products. This is the 7 times the 8. This is the 7 times the 40. So this is I should be putting 280 if I was doing true partial products. This is the 60 times the 40, okay? And you'll see that in a minute. And then we're adding along the diagonals, which have been positioned so that they're in the appropriate place value. So we add this, and we'll carry, if we need to, up to the top of the lattice, the corresponding lattice. I'm going to do it in a different color so that we're kind of drawn to those numbers that I'm carrying. It's so easy to leave those off. Okay, 21. This should be familiar. We did have, 6 ones and then this one here. So there, it's matching up. Okay, we're 8, 12, 18. Okay, 11, 12, and then the 1. And then your answer is here, okay? So 12816, 12,816. Okay, like I said, this is it's kind of a strategic partial product. So let me show you the partial products to show you how there is a connection and why the lattice works, because it kind of seems like this magical thing, and I don't like that. I want you to really understand it. If you're going to use it, or if your students are going to use it, they need to understand it, you need to understand it, and why it works. So show them partial products and have them do partial products for a while if you're going to move to lattice, if they like that, before kind of moving on. Even to this, I think that partial products are important to just see why this works. It's not magic. It's doing the correct thing. Use manipulatives first, all those good things. All right, so partial products, we're going to separate everything out into place values. So the 267 I'll write as 200 plus 60 plus 7, so expanded form. That's why we learn expanded form. Okay, and we're multiplying it by 48, so I'll write 40 plus 8, expanded form. And then we're going to do the distributive property, taking each number here to each number here. So the 200 times the 40 and the 8, the 60 times the 40 and the 8, and so on. Making sure to use that correctly and get all the partial products. So we'll start that. Some students like to do this in a box and write like 200, very similar to lattice, 260 and 7, and then the 48, and do the multiplication in the box and then add all at the end. Okay, so that's fine as well, and really echoes that lattice algorithm without all the zeros. Okay, the lattice uses no zeros. So 200 times 40, okay, is going to be 8,000. And hopefully you're seeing these values. That's this box right here. This is the 8,000, okay? The 200 times the 8, so, excuse me, 200 times the 40. Okay, 200 times the 8, that's going to be this box right here. It's going to be 100, it's going to be, 1,600. Okay, so 200 to each number, and then 60 to each number, 60 times 40. Okay, 2,400. Once again, seeing these numbers, here's that 24, and you can see that that 4 is lining up with the 6 that was in the hundreds place as well with the 1,600, okay? All right, so 60 times the 40 is what I just did. 60 times 8, 6 times 8 is 48, so this is 480. All right. And then I'm going to take the 7 to the 40 and the 7 to the 8. So 7 times 40 and 7 times 8. And so hopefully you're seeing this connection. 8,000 is right here. 1,600 is right here. The 200 times the 80, 200 times the 8. Okay, the 2,400 the 480, the 280, and the 56, and how everything's lined up in the correct place value. And it's really cool that it works in this way, and numbers the way they work. So it's not magic, it's math, okay? And if you do all this addition, you once again get the 12, 8, 16. All right, so there are 3 multiplication algorithms for you.